Hi, everyone. I'm Mina, and I have Marco here with me.
Hi.
Sorry about the background. And we are Android engineers at Careem. For those of you who don't know Careem started as a ride-hailing company in the Middle East in 2012, and it got acquired by Uber last year. Careem operates in like 100 cities across 14 countries. Marco and I, we work in the mobile platform team at Careem, and our team is mainly working on performance improvements, monitoring, CI, app stability, and recently becoming a cross-platform team. So we have been recently obsessed with sharing everything with iOS apps. So that's where Kotlin Multiplatform comes in. Recently, our team has been obsessed with sharing everything. So we've been running Kotlin Multiplatform for over 2 years now in our production app, and it's been going really well. And by well, I mean, if we have bugs, it's not because Kotlin Multiplatform, it's because we did something wrong. So overall, it's going really good. And having said that, as our business is growing, our application is becoming more of a platform. And since then, we have been going cross-platform and everything is implemented. We're trying to implement everything, every new feature. We're sharing the business logic there in Kotlin Multiplatform. And also sometimes we implement the features, like till the presentation logic, of course, not the UI. That's all. And so over the last 2 years, we've been gaining more trust in Kotlin Multiplatform, and we've been taking a little bit of risk every once in a while. Let me see. So let me tell you a little bit of context on how we started. So we started with just Kotlin Multiplatform was just callbacks. We did the whole core business logic for our application, for our Captain application, the Captain for the driver app. And it was just pretty straightforward, just Kotlin Multiplatform and callbacks and lambdas, but no multi-threading, of course, no nothing. But it gave us trust in Kotlin Multiplatform. Next, we took it a little bit further, and we introduced some multi-threading and reactive streams. So we used here like reactive library. It's by Badu. It's a very nice library. And we added it to our production app since the beginning of this year. And it's going really well so far. Till like last quarter, we also introduced a new SDK. And for this SDK, we went all in. So we did everything from Kotlin Multiplatform side. We multi-threading, networking, persistence, support for even backend and Node.js. So the SDK is actually supporting everything in the company, from mobile to backend and everything. But of course, I mean, we were careful when it comes to this app for this SDK, because it's a huge step for us, and we have to have some trust for the SDK before we push it to production. And of course, we were careful enough to have testing. But of course, it's not that simple to test in Kotlin Multiplatforms, given that there is not enough frameworks to test with. So we were able to write unit and integration tests and everything with the help of a library we implemented, because we cannot simply assume that if the tests are passing for JVM, it will pass for other platforms. So we have to write everything in common, including the integration tests. So we use this library to help us in mocking. And the reason why we needed to run everything in common is because, for instance, when we started supporting Node.js, we ran the test against Node.js or against JavaScript, and we find a simple bug, like we were using a regex that doesn't work for JavaScript. I would never ever know if we just let it run for JVM. And we will show you cases where the same issue happened with iOS, especially with the concurrent invalid mutability exceptions. Okay. So today we will show you how to write a feature, and more importantly, how to write unit and integration tests for this feature in common, of course, and it will be a production feature. So what we will show you is actually running in our production. Okay. So before we talk about the feature and the testing, let me tell you why we are pushing to go even for features to be implemented in Kotlin Multiplatform. So first of all, it's cost saving, and developer productivity is better when everybody's contributing into the same code base. We're sharing the same common logic. We will have some alignment and consistency. Like if you test it well, it works for all your platforms. You have a bit of consistency. Also time saving, but there's a catch here that if you want to save time, you should, if you're going with mobile at least, you should think mobile iOS first. If you go with Android, you will have issues with the concurrency model. So when we say time saving, yes, it saves time, but you have to consider iOS at the beginning. And of course, Kotlin is fun. So this is a simple to-do list app for the feature. This is how it looks like. We just did this code is, by the way, we will share it on GitHub after we're done. It's just a simple to-do list app where you can just add and list down your to-dos. We have persistence as well. We're using SQLite for persistence. So even if you relaunch the app, you get to see your to-dos. And we will show you how we wrote unit and integration tests for this. For the integration tests, we were also able to test with SQLite. That's why we added it in the sample so that we can give you a sample of how you test third-party libraries as well. Okay. So the architecture we used was MVVM. It's up to you, even if you want to implement it in a different architectural pattern, it's fine. We just chose it, and everything is done in Kotlin Multiplatform, except the view side. Okay. So just bottom up, let me tell you quickly what is the architecture. We have the repository layer. The repository have two data sources. One of them is in memory, just for caching, and the other one is the persistence one, which is using SQLite. As you can see, everything is interfaces. So we use interfaces so that we are able to mock our dependencies, to test it well, and also to have the freedom to inject different kind of implementations from the beginning, from the DI graph we have. If we go a little bit further, the use cases we implemented have a dependency on the repository layer, of course, to add and fetch everything. And also they are, of course, interfaces, but you can see that they are reactive. So we are providing streams so that the view model can provide streams for the view to update. So for the view model, it has dependency on the use cases. And the view model itself, this is the contract for the view model. Of course, initialize and destroy. We use these, like, it's up to the view for each platform. So it's up to the view lifecycle, for instance, Android, of course, and initialize on create and destroy, on destroy. This is the stream. So this stream is where you keep getting updates for the UI, for the list of your to-do list. Whenever you add a new item, if you subscribe in the beginning, when you initialize and you fetch the persistence, you will get the persisted data at the beginning. And of course, the function that you use to create a to-do when you click on to-do. This is quickly the implementation. What I want to show you is just, for the stream, we're just using a behavior subject from reactive library. And it's just, we just emit whenever there's a change in the list, and the view will directly get the updates. Now, I will give the mic to Marco here. He will talk to you a bit about Mockingbird, which is the library we implemented for mocking dependencies.
Good morning, guys. So let's now talk about Mockingbird. So at the beginning, when we started writing all our tests in JVM test. And this was working fine as long as we were using a single threaded environment, because the tests were super simple. We were just testing logic, and the logic was able to be tested also only on JVM. But then when we start moving forward with our approach and go deeper on multi-threading, this approach wasn't working fine anymore, because now the platform were playing a role that before we didn't face. So in particular, the problem is what we want is to move all our tests from JVM in common tests. So to do that, what we were looking at is what we are using in Android that we don't have in Kotlin Multiplatform, for example. So the first thing that we notice is that people are in the Android ecosystem are really used to mocking libraries like Mockito or Mockingbird or Mockay. So to make the team comfortable on the migration to Kotlin Multiplatform, we had to provide them a way to write tests with a mocking library. Another point why mocking library are useful is because first, people are used to it. And second one is that if you don't use mocks, probably you have to create stubs for each test and stub your behavior. With a mock, you can create different behaviors in a faster way. So what we did. So we create this library, which is a Kotlin Multiplatform library. It's running on JVM, iOS, Android, and JavaScript. So the other point that we want from this library, we wanted this library to support the Kotlin native concurrency model. Since this is one of the main differences between the JVM world and the Kotlin native world, we need this library to support this new model. And then, so we were looking at the community and what was around that for mocking libraries, and we didn't find alternatives for mocking libraries. So we also start thinking about how we can help the community with this, and we decide to go and open source this library. So about the features, what we provide are basic features. In particular, we can mock behaviors, create spies. We have different ways of doing argument captures. We can, of course, verify invocations on mocks and spies and use different measures. So what we will see today about Mockingbird. So today we will not go deeper in the library itself, but we will see the basics that we will then use on our unit tests and integration tests to be able to write them in the common folder. So first of all, we will see how to create a mock. Then we will see how to create a spy. And in the end, we will see an example of how to use those components. So to create a mock, let's say that we want to mock this to-do list repository. And we want to create our mock class. So the first thing that we have to do is we need to extend our class and extend the mock type of the library. After that, we need to provide a way to the library to know which is the method we are mocking and referring to. So we need to create two objects, method and arguments, where we need to specify the mapping between the giving a name to a method and the method itself. Then we override the functions from the object that we want to mock. And in particular here, what we will use two utility functions provided by the library to allow us to record and mock behavior on the specific function. So here we have two utility functions, the mock unit and mock. So the first one is, as the name say, to mock unit functions. and the second one for non-unit function. So there is a different behavior here, like the mock unit function by default is relaxed. So if you don't specify any specific behavior and you don't override it, the invocation will just record the invocation, but it will not do anything else. Instead, for mock, you cannot relax, and you have to specify the behavior that you want when the function is invoked. The arguments of these two utility functions are the method name, where we are using the method defined before on the object as the name of the method, and we provide a list of arguments where it is a map of the name of the arguments itself and the actual value of the arguments. So this will help the library to record invocations and be able to use them later. Then we can see how to create a spy instead. So a spy is similar to a mock. Let's have a look at our persistent to-do data source object. And the difference here is that you have to use spy instead of mock. And the other key components is the delegate. So a spy by default is delegating the logic to the real implementation. So you need to provide the real implementation as a dependency of your spy object. And when you actually write the implementation, you use spy instead of mock, and you will have an extra argument, which is the delegate callback, where you have to specify which method on the delegate you have to call if you don't override the behavior. So now let's go back to Mina, and he will drive you through an example of how to use the library for tests.
So let me show you how to quickly use a mock with an actual example from our sample app. So let's take this use case, which is the add to-do use case, which has a dependency on the to-do list repository that Marco was just showing you the mock for it, and another simple class, which is timeutil. Everything is interfaces, so we are able to mock it. You can see here that we are calling timeutil.get time in millis, which is simply returning a long of the timestamp. So for this function needs to be mocked because it expects a long, so it's not relaxed. So let's check the test. You can see at the beginning we are initializing our mocks, and when we instantiate that class, the subject class, you will see that we are passing the mocks and the dependencies. And then, since we are using timeutils and we need to mock its response, in the test, we can do it in the before, or it's up to you. If it's a test that has different values, you can do it for each test case. So we just call every on the method, and then we say that the method name we want to mock is get time in millis, and we return this timestamp. You can see it in the companion below. Now for a test case, let me show you how we can verify. So for this test case, we're preparing our test data. So we have a sample expect test item, and then we're calling the execute on the to-do string. So we're persisting the to-do. And what we're expecting here from this behavior is that timeutil have get time in millis called. And for the repository, we want to make sure that add to-do function is called. You can see that in the get time in millis, since it doesn't expect any arguments, the arguments is not there because it's optional. But for to-do, for adding to-do, it's expecting an argument of to-do item. So we're passing the arguments map, and we're passing the expect test item we instantiated at the beginning. But what if you just want to verify that add to do is called, but you don't care about what was the value passed in the arguments? So in this case, you can just use any. So here, any, what we care about is, of course, that there are arguments passed. Otherwise, if you don't pass this, it will fail. Pass the arguments map. But at the end, what we care about is that add to do has been called, right? There are cases where you want to capture as well when it comes to, you want to verify a property in your in your arguments, but you don't care about the full object. So in this case, you can use a slot. So you instantiate the slot, passing the to-do item as the type. And then in the map arguments map, instead of passing the actual value or any, you capture the time item slot, and then you can unwrap it and get the captured value and assert on anything. So for example, for this one, we just assert on the to-do item inside it contains any string. That's pretty much it. This is the basic functionalities that you can use and you usually do on your day-to-day work when you write unit tests. So now let's move to integration. Oh yeah, before we go there, I want to give you some notes about this. I know it's painful that we write mocks this way. We have to implement the whole mock. So what's going on right now is we are implementing a Gradle plugin to help us generate the mocks and spies instead of implementing it ourselves. And also we are open sourcing this library soon. So once we open source, we would appreciate feedback so that we can improve it, of course. Now, the next part is how we will show you how to write integration tests. Marco will show you how to do it.
So let's now talk about integration tests. So first of all, why we want to write integration tests in the first place. So on Kotlin Multiplatform, when we start writing code for our internal SDK, we were facing multiple challenges. In particular, the platform was having different behaviors. One of those was the different Kotlin concurrency model. So one of the things that we want to achieve is that we want the same behavior on whole platform to have our tests shared in common in order to keep the whole integration consistent. So why unit tests are not okay to this point? So on unit tests, what you're testing the logic of your component in isolation kind of thing. So you don't care at that point about which thread will run this kind of test and other issues of this way, these kind of issues. So what we want to test this whole integration with the different threads. So we want to test the component in the environment where it will run. Another problem is on Kotlin Multiplatform, we try to keep as much code as possible in the common folder, but for some specific cases, you have to write your specific code on a platform-specific one. And since you will write two different code for two different platforms, by nature, the behavior might end up diverge or become inconsistent. And you want to keep this consistent to be able to have your feature stable and working in production. Another thing is then the third-party libraries. So third-party libraries in Kotlin Multiplatform, we have many, and some of them are not supporting all libraries. Some of them have different issues with the Kotlin concurrency model. And so on our integration test, we would like to have the confidence to say, okay, this in third-party library is working fine with my integration as well. So what we will see today. Today, we will see how to write a simple integration test, and we will start showing you how to generalize platform-specific dependencies and how to keep your integration test platform agnostic in such a way that you can write your integration tests in the common test folder. Then we will show you how to set up the base class for the platform-specific part that will run on iOS and on Android. We will spend some words about how to create a DI graph that is good for integration test purposes. Then we will actually see a real example of the test. And at the end, we will see how those tests will help us catching an invalid mutability exception, for example. So let's have a look at how we can abstract from the platform dependencies. So platform dependencies are different in Android and iOS in the sense that if you look at Android, we probably need the context or the application context on some cases, like for database or for any other things. So to do that, what we need to provide these platform dependencies as an expected class, and the actual implementation, it depends on the platform. So we are using the test injector to help us on getting the platform dependencies from a common place where under the hood, the platform dependency is generated on the specific platform. The other key component is to keep all the tests in common test. We need a way to find a base class that is different in Android and iOS in order to handle the ecosystem properly. So in Android, what we need to do, we need to have these tests like a roboelectric test in order to be able to get all the SDK and environment from Android. In iOS, we don't need that because when we compile for Kotlin Multiplatform, we will get already the environment for iOS. So let's have a look at a DI graph. So what we want from a DI graph is we want this DI graph to be as close as possible to your real environment. So the DI graph that you are using in production should be as close as possible to the one you're using in integration test with some minor changes. Then what we want as well is to keep them in common. So the point here, we want to share logic. And so to share logic, keeping the DI graph in common is a way to guarantee the consistency between the way you build your components together in different platforms. And then what we want is, on the integration test specifically, we want to be able to override some of those dependencies because we want to spy them, because we want to have some decoration on top of it for our purposes of the integration. So this is the example, the DI graph or our test app that we will share later. And in particular, let's focus on the two data sources mentioned before by Mina, which is one in memory and one using persistence. So how do you instantiate a DI graph? So for example, based on your scenario, in Android, you instantiate, for example, the production one, given a platform dependency with the application context. In iOS, it's similar, but you don't need the application context. And then you need to have a common way in the integration test to be able to instantiate both. So for the integration test, what we use is a test DI graph, but we ask the test injector to give us the platform dependency. So let's have a look at how we extend a DI graph for integration test for our purposes. So what we are doing here, we are extending the production one, and respect to it, what we are trying to do, we are spying the specific dependency. So in this way, we can access it later and check some behavior on it. So this is the integration test. To write the integration test, we extend the platform integration test class that we saw above. So this is in common. The platform integration test is specific for platform, and you don't care at this point. And then what we do, we instantiate the test DI graph. We build it using our test injector, so we will get the platform-specific dependency. And that's how we build it. Notice here that since our integration test is testing also the integration with third-party libraries, we are actually persisting data on a real database on Android and iOS. So what we need to remember is we need to clean it up after our integration test, for example. So let's have a look at the specific integration test case. So here, what we want to do is we want to initialize our view model. We want to subscribe to the stream of to-dos. And in the first place, we want to say we don't have any to-do. And then we want to create a to-do. After this, what we want to verify that the to-do has been added in memory, the to-do has been added in persistence, so on the database, and that we will get a new emission on the stream. So let's have a look specifically how we can verify that the memory has been inserted, for example. So here, the part that is interesting is that we can access our DI graph. From our DI graph, we can ask which is the memory data source. And since the memory data source is a spy from Mockingbird, we can actually verify an invocation on it. So using the verify, we can specify the method name that we want to see, like, okay, I want to see that I added it a to-do of a specific value on my data sources. So I can use capture to get this to-do insertion and assert that the content of the to-do is the content that I was expecting. For persistence, it's quite similar. So we are getting the persisted to-do data source, and we are calling the verify on the same method, verifying the same content. So let's now have a look how this integration test can help us on invalid mutability issues. So this is an in-memory implementation, for example. We're just using a mutable list and to store the data. So let's run this test on Android. It's working fine. Let's run the test on iOS. In iOS, this is not working because of the invalid mutability exceptions. So let's go back. So here, what we are doing, we are saying, okay, our data source is supposed to be an immutable object which is keeping reference of a resource. And this resource is mutable. So the problem is with the Kotlin concurrency model, you cannot do that. So your resource has to be or detached by the graph or immutable if you want to share across multiple threads, because this data source can be used by multiple threads. So to fix it, what we have to do, we can use the isolate mutable list from stately of TouchLab that under the hood is using the touch graph to access the resource for the owner thread. And this way we are not mutating the immutable data source that we want. After this change, when we run the test, Android is still passing, and iOS at this point will pass as well. So here, with the integration test, we were able to catch a different behavior of our component. And so this will give us the trust that when we build it and the integration test passes, we are ready for production. So to conclude, we should share business logic where it makes sense. We shouldn't force it. Sometimes you want to share, but it's harder than don't share. In that case, don't share. Another point to keep in mind is think iOS first when you're building Kotlin Multiplatform library, because the concurrency model of Kotlin native is more strict than the one for JVM. So if you build for the one which is more strict, automatically it will work for the one which is more relaxed. Testing is crucial for consistent behavior across all platforms. Kotlin Multiplatform is supposed to work on multiple platforms, but what you want to achieve is the same behavior. So writing a test that tests not only your logic of your component, but your overall behavior is crucial to achieve this. Another important point is that writing tests faster is crucial for productivity and achieve lower costs. So here, libraries like Mockingbird can help you keep the costs low and write faster tests. So here we have a couple of references, and we are open for questions. Mina? Which one is mine? This one?
Is Mock-A still mature enough for multi-platform projects? So at the time of writing this library, no, it wasn't. As far as I remember, it was not supported.
It's not supporting Kotlin native, for example.
Yeah. What's next? Interesting to see you used reactive instead of stateflow. What made you favor reactive overflows? So the actual reason we started with reactive, we were comparing between flows. Hold on, state flow. No, actually, we're comparing between reactive and flows from coroutines. But what we made us go with for reactive is we had more capability of contributing back to the library, and also we had the power to change the behavior. Like we were able to change whatever we want. We were able to contribute, so we felt more comfortable using reactive.
And also, so coroutines didn't have the multi-threading support that we were expecting. And we tried to integrate some coroutines, and they didn't work well for our use case. Instead, we found out that reactive was working very well with the Kotlin native concurrency model without major issues.
Do you have a link for the sample? Yeah, we will share it like right after the talk. We will share it. You will get a link, and you will be able. We ship the artifacts for Mockingbird because we're not open sourced yet. So you just need to follow the steps to build it, and you will be able to run the tests and run the app itself.
Yes, the time until could have been a fake. So why we want to verify was just to show how to use the library, not specifically for the test purposes. So about dependency injection framework, we didn't implement any dependency injection framework. We just built our DI graph by our own. So we define our own scope. In production, we are using Dagger as well. So it depends how far you go with the integration. So if you delegate your platform-specific code to build your DI graph, you can use Dagger, for example, and this is what we are doing as well. But you can go deeper and try to abstract the concept of DI graph and build something on your own.
Okay, does not work for pure Android.
Why? What I didn't get the question
as well. I'm sorry. How do you test components that require physical user like fingerprint?
We didn't have this use case. That's it.
Yeah, see. Okay. So thank you, and right after the talk, we will share the link for the GitHub link for our sample project. And just all you need to do is follow the steps in the README, and you will be able to run it. And please reach out if you have any questions or you want to have any discussion about what we talked about today. Yeah. So about this. Yeah. So the thing is, we didn't go through deeper yet into these kind of use cases. But basically, usually, if we usually doing everything in an abstract way where we can mock it. But of course, if you want to test the actual thing, then yeah, it will be a bit painful, especially if you're trying to test fingerprint on both platforms.
Also, because that's a thing that is really platform specific, and maybe you don't want to share this logic in a sense. So you want to create an interface, rely on that interface, but you actually test the real implementation, for example, with the integration test.
Also, usually
you just give the fingerprint as one of the platform dependencies. So the implementation of the fingerprint will be one of your platform dependencies. So you will still be able to run your integration test, but you will have an extra platform dependency because this is something that you will not share.
Thanks. Thank you. Okay.
Thank you everyone for attending. and we hope you enjoy the talk and have a good continue of the droidCon. Bye.
Bye-bye.